To question number 2. Write orbital diagrams for each ion and ion is diamagnetic or paramagnetic. So this is 2. So before I write out all of the different orbital diagrams, I'll give definitions for both diamagnetic and paramagnetic. So when you have diamagnetic, there are no unpaired electrons. And then for paramagnetic, it contains unpaired and an unpaired electron. Okay. So our first ion is V plus 5. So this is vanadium, I believe. So first I'm going to write out the electron configuration for just a neutral vanadium ion. Well, not ion because it's not charged, but basically its electron configuration is the argon, 4s2, 3d3. So when you have a 5+ charge, then this means 5 electrons were removed. So its electron configuration changes, and it actually has the same electron configuration as argon. So these 5 electrons are now gone, and since it has the same electron configuration as argon, I'm just going to write it in the long form, which is 1s2, 2s2, 2p6, 3s2, and then 3p6. So in terms of the orbital diagrams, I'm just going to write out this electron configuration as like different energy levels. So the bottom one will be for 1s, 2s, and then for 2p, looks like that, 3s, and then 3p. And when you draw out the electrons, you do it starting from the bottom to the top and then left to right. So I'm going to show how I fill it in. When I get to like multiple, I do all of them standing up first and then pointing down. It's just good practice, even though we know that all of these will be filled. So therefore this is diamagnetic since there are no unpaired electrons. Okay, so let's do the same thing for B. So I'm going to draw out the long electron configuration for chromium. Okay, so now since it's chromium 3+, it means it lost 3 electrons. So we're going to take out the 1 here, and then we're going to take out 2 from the 3d5. And just to shorten it, its new electron configuration will be argon, and then 3d3. So let's draw out its diagram as well. I'm gonna run out of room. I'm just gonna draw the upper d orbital. And draw in the last 3 electrons here. So just to show I skipped all of the argon electrons and just went straight to the 3d. It shows that you have 3 electrons and none of them are paired, so therefore this is paramagnetic. Okay, so let's do the same thing for nickel. So its electron configuration for nickel 2+ is 1s2, (3d8). So this is nickel 2+'s most stable form. And again, I'm just gonna write out just that 3d just to save space and time. And then I'm gonna write out the 8 electrons. So all the ones that are positively spinning, I'm gonna draw out first. So that's 5. And then I'm gonna draw in the last 3. And you'll notice there are 2 unpaired electrons. So therefore this is also paramagnetic. And then let's look at the last Fe3+. It looks like this. So I'm also just going to write out the 3D and fill out the 6. So you can see that there are a lot of unpaired electrons. So this is also paramagnetic. Okay, so let's see the answer from our junior tutor. two orbital diagrams for each ion and also indicate that. So A diamagnetic, B paramagnetic, C, D paramagnetic. A species containing one or more unpaired number of electrons is said to be paramagnetic species, and the species containing paired electrons only is said to be diamagnetic species. Atomic number for vanadium is 23. The charge on vanadium ion is, so 5 electrons will be removed. Yep, so that looks right. Looks like they meant to draw out also the electron configuration. Okay, so they explained all of the different diamagnetic and paramagnetic, so I'm just going to say answer is correct. And then I'll just briefly write out their electron configurations. Okay, but solution is still correct.